practices involving GMOs. It is important to establish transparent communication channels between farmers, consumers, and regulators. Clear labeling allows consumers to make informed choices about the foods they purchase. 3. Global acceptance. The acceptance of GMOs varies across countries and regions due to differing perceptions of risks and benefits. Establishing international guidelines for the adoption of gene editing techniques in agriculture is necessary to avoid trade barriers and promote global cooperation. 4. Intellectual property and access. Access to gene editing technologies should be equitable and affordable, ensuring that small-scale farmers and developing nations can benefit. Balancing intellectual property rights with the public interest is essential for fair access to these technologies. 4. Future directions and challenges. 1. Precision and off-target effects. Despite their remarkable capabilities, gene editing techniques like CRISPR-Cas9 are not always 100% precise, and off-target effects can occur. Further research is needed to improve the accuracy and minimize unintended genetic modifications. 2. Public perception and education. Public understanding and acceptance of gene editing in GMO farming are crucial. Education initiatives need to be developed to provide accurate information about the benefits, safety measures, and potential risks of these technologies, fostering informed public discourse. 3. Biodiversity conservation. As gene editing becomes more prevalent in agriculture, it is essential to consider the potential impact on biodiversity. Preservation of wild relatives of crops and maintaining genetic diversity within agricultural systems should be prioritized to safeguard ecosystem resilience. 4. Long-term monitoring. Continuous monitoring of gene-edited crops is necessary to assess any unforeseen environmental impacts or changes in genetic stability. Robust monitoring programs must be implemented to ensure the long-term effects of these crops are properly evaluated. This article will explore the various gene editing techniques utilized in GMO farming, their potential benefits, and the ethical considerations surrounding their use. Understanding gene editing techniques. The CRISPR-Cas9 system is a powerful gene editing tool that enables precise modification of DNA sequences. Cas9, an enzyme, acts as a pair of molecular scissors that can cut DNA at specific locations determined by a guide RNA molecule. Scientists can then replace or modify the targeted gene, integrating favorable traits into a plant/its genome. Transcription activator-like effector nucleases, TALENs, are another gene editing technique that can modify target genes. Similar to CRISPR-Cas9, TALENs enable scientists to cut DNA at specific sequences, allowing for gene replacement or modification. Zinc finger nucleases are engineered proteins that can recognize and cut DNA at specific sites. Like CRISPR-Cas9 and TALENs, ZFNs provide researchers with the ability to introduce desired genetic